Good morning, everyone. This is Mrs. Mary Ratnanita once again, welcoming you back to your pharmaceutical microbiology class. The topic for today's our class is official methods of sterility testing of pharmaceutical products. So, since we are pharmacists and we manufacture different products, so whatever the pharmaceutical product which is manufactured, let it be any formulation, let it be a tablet, let it be an injection, let it be a cream, let it be an ointment, any product, you have to check this product for its sterility. Now, what is the sterility? What are these tests for what is this test for sterility? We'll see in a topic for today. So before learning that, we have to learn what are the learning objectives which are to be learned in this topic. So by the time we complete this topic, I can say that I can assure that you guys shall be in a position to define what is sterility or what is test for sterility, what are sterile products, some important definitions. At the same time, you'll be having the knowledge or you'll be acquiring the knowledge about the list or the steps that has to be followed, sequential steps that has to be followed in order to perform the sterility test. And also you'll be in a position to explain different methods of sterilizing, testing the pharmaceutical products. So these are going to be our learning objectives. And so coming to our main topic, that is test for sterility. When you define test for sterility, before defining the test for sterility, we'll see why the sterility has to be, what is the sterility and why the sterility has to be tested. So sterility test is used to identify the presence or absence of a microbial organism, microorganism in a pharmaceutical product. Let it be any product, let it be an injection or ophthalmic product or ointment, any product, and even including your surgical items like your absorbent cotton, your IV sets, your disposable syringes, anything, you have to check whether these products are containing any microorganisms or not, because there is a hard and fast rule that whatever the products which we are preparing should be completely free from microorganisms. As we already know that sterilization is nothing but complete removal of microorganisms irrespective of their use. So we are not going to bother whether they are useful organisms or whether useless organisms or they are going to be harmful to us. Whatever the reason might be, you have to remove the entire microorganisms present in that particular product. So that is nothing but your sterilization. So sterile means the product where the microorganisms are completely free from microorganisms, or microorganisms does not grow or develop. So such products can be considered as sterile products. Now, this sterility product, whatever the test for sterility we are talking about, this test for sterility has to be carried out in aseptic condition. Now you might ask, why, ma'am? So why? Because we are trying to check the product for the presence of microorganisms. If at all we don't maintain an aseptic condition while checking the product, there is every possibility, since we know that microorganisms are everywhere, especially in the air also. So if we don't maintain aseptic conditions, the air comes in contact with the pharmaceutical product which we are testing, and there is every possibility that we might get a wrong result because of the contaminants from the outside rather than present in the product. So that's why it is hard, and there is a hard and fast rule that whenever you're performing this test for sterility, it has to be performed in aseptic condition only. Now, talking about the definition of the test for sterility. Now, when you define the test for sterility, so the definition states that the microbial test used to detect the presence or absence of viable forms of microorganisms in a pharmaceutical preparation is called as test for sterility. So, microbial test, this is nothing but a test that is performed where on a pharmaceutical preparation. Why are we performing this test? In order to find out whether microorganisms are present or absent. If they are present, in which form, whether they are viable form or dead form, whatever the reason is, you have to find out whether the organisms are present or not. That procedure is called as test for sterility. Now, talking about the principle, which is basically involved in your test for sterility. So when you're talking about the principle, generally we know that when microorganisms are taken and they are supplied with required nutrients, and when they are given sufficient, when the required environmental conditions are maintained, and when you incubate them in suitable temperature conditions, they grow and multiply. So their growth has to be identified, and their growth can be seen as turbidity in the clear medium. So what we do, we try to check the product if they are showing any turbidity or if they're showing any growth of the microorganism or not after its complete manufacturing. Before releasing the product into the market, the product has to be tested for sterility. If at all, if there is any turbidity present or if there is any microorganism present in the product, that entire batch has to be discarded, because it is not acceptable for the presence of any kind of microorganisms in the final product of the final pharmaceutical product. Let it be any product. Now, let's see what are the different steps which are involved in your sterility. So, sterility testing is just not a simple thing that you take a product and you just go for testing it. No, you have certain sequences, certain orders, certain method in which you have to test this product. So, under this, the first step is preparation of the culture medium. What culture medium, what type of culture mediums are generally used in order to test these products is very important. Second one is sampling, that is selection of the size of the sample. Then third, determination of sample quantities to be used in each culture medium. When we are dealing with each and every step in detail, I'll let you know what are these. Then fourth step is preparation of dilution fluids, and fifth is test methods, and sixth is interpretation of results. So once you carry out the entire 6 steps, then only we can say we have completed the test for sterility. Now, talking about the first step, that is preparation of the culture medium. So, in order to perform the sterility of a product, in order to test the sterility of a product, there are different culture mediums available, and generally we use these culture mediums in order to test the product. So, there are 2 different mediums which we generally use. One is fluid thioglycolate and alternate thioglycolate medium, and second one is soybean casein digest medium. So these are the 2 different mediums which we generally use to perform the test for sterility. And talking about the first medium, that is fluid thioglycolate medium, generally this medium is used for anaerobic organisms in order to check the presence of anaerobic organisms. Also you can use it for aerobic, but to limited extent. So when you talk about the composition of this medium, you have L-cysteine in this, sodium chloride, dextrose, agar, yeast extract, pancreatic digest of casein, sodium thioglycolate, risazurin, distilled water. Here agar is used in order to increase the viscosity of the medium so that you can decrease the diffusion of oxygen into the medium. So thereby, as I said, it is mostly used for anaerobic organisms. And then here risazurin, it's an indicator, it's an oxidative reduction indicator. And sodium thioglycolate, it is used in order to find out the presence or absence. So here, if at all, the way you are using sodium thioglycolate, if you use thioglycolic acid, that will become your alternate thioglycolate medium. So the composition, entire composition is same. Only ingredient that will be changed is sodium thioglycolate. In place of sodium thioglycolate, you take thioglycolic acid. If you take thioglycolic acid, that will become thioglycolate medium, alternate thioglycolate medium. If you take sodium thioglycolate, it will become fluid thioglycolate medium. So this is the composition of your fluid thioglycolate medium, and generally this fluid thioglycolate medium is used to test, most importantly, it is used to test the products which are viscous and oily in nature. And second medium is your soybean casein digest medium. And soybean casein digest medium, it is also used in order to test the presence or absence of bacteria and fungal forms. And here the composition of the soybean casein digest medium is pancreatic digest of casein, peptic digest of soyamine, sodium chloride, dibasic potassium phosphate, dextrose, and distilled water. And this soybean casein medium is generally used, both the mediums are mostly used for testing your test for sterility. So that is your first step, preparing your culture mediums. So 2 kinds of culture mediums, fluid thioglycolate or alternate thioglycolate media, and soybean casein media. So both culture mediums are generally used for testing the sterility of a product. Now coming to the sample selection. Now When you're preparing or manufacturing a product, you will not manufacture it in ones or twos in numbers. You will be preparing it in a lot, right? Either they contain hundreds or thousands. So depending upon the kind of product, depending upon the type of formulation, the batch size increases and decreases. But generally, it contains a group of number of items in that a particular product. For example, if you're preparing an injectable, definitely one batch might contain 100 ampules or 100 vials. It can be of any kind. The container can be of 10 ml, 20 ml, 50 ml, but the number would be either 100 or what, because you won't manufacture only one ampule of particular injection or two ampules of particular injection. So there'll be a lot of number of ampules present in particular batch. Now, when you're testing the sterility, you just cannot completely put all the take the entire batch and go for sterility testing. No, when you're cooking rice, definitely what will we do? We'll just see one grain or two grains to check whether the rice has been cooked or not. And basing on that, we say that the rice is cooked or it is not yet. It is yet to be cooked. The same way, we are not going to use the entire sample, entire lot for testing the sterility. If one ampule contains contamination, then the entire batch contains contamination. If one ampule shows complete freeness from the contamination, that means the entire batch is free from contamination. So you need to select the number of containers to be used to test the sterility. So that is your second step, that is sampling. So for this, that is Indian Pharmacopoeia has given you certain standards in order to pick up the minimum number of items from a number of batch that is generally manufactured. So when you talk about the number of items in the batch and minimum number of items to be checked, if it is an injectable product, for example, if the lot contains or the batch contains 100 containers, then you have to take 10% of 4 containers. That means you have to take 4 containers, and from that 4 containers, 10% of the product has to be taken for sterility testing. Then if at all the batch contains more than 100 and less than 500 containers, then you have to take 10 containers to test the sterility. And if it contains more than 500 containers, then 2% of the 20 containers has to be collected and tested for sterility testing. So this is how you check the samples for testing the sterility of the product. Now, third step is your determination of sample quantities to be used in each culture medium. Now, as I said, batch contains lot number of products. Now, each product might contain, the container might contain different quantity of the product. Like if certain ampules contain only 1 ml of the injectable, certain ampules contain 5 ml of the injectable, certain vials contain 20 ml of the injectable. So depending upon the container also, you can, if you are taking, for example, in the previous example, as we said, if it is more than 105, less than 500 containers, you have to take 10 containers. For example, if the container contains 100 ml or 50 ml of the product, you just cannot pour the entire 10 containers product and then check it. No. So in that way, you have to find out what is the amount of sample to be taken from each container in order to check the sterility. Now, for this also, IP has recommended certain standards. If at all the container contains only less than 1 ml of the product, then you have to take the entire content of that particular ampule or vial or that package and then use it for sterility testing. If it contains more than 1 ml, more or equal to 1 ml and less than 4 ml, then half of the content has to be taken. If it contains more than or equal to 4 ml but less than 20 ml, then 2 ml of the container sample has to be taken. If it is more than or equal to 20 ml but less than 500 ml, then 10% of the contents has to be taken. And if it is more than or equal to 100 ml, then not less than half of the container is to be taken. So this is how you have to take the sample and you have to go for the sterility testing. Now, fourth step is preparation of dilution fluids. You might ask me why these dilution fluids are required in order to test a sample, madam. So when we are testing, as I said, all kinds of samples, all kind of products, all kind of formulations have to be tested. It can be an ointment, it can be a emulsion, it can be a powder, it can be anything. So directly you just cannot or it can be an oily item. So all these items are not soluble in the media, or directly they cannot be added. So in order to add these, or in order to easily facilitate the method of sterility testing, we prepare your fluids, diluting fluids. So generally we have two diluting fluids, fluid A and fluid B. Now, when you talk about the fluid A, how to prepare fluid A means you have to take 1 gram of peptone and add it to the water and make it to 1000 ml. So you are adding 1 gram of peptone in water, and 1000 ml is made up, that solution is made up to 1000 ml. This 1000 ml solution, what you have made, has to be clarified. Clarification in the sense filtered or cleared. So it can be clarified either by filtration procedure or it can be by centrifugation procedure. Once the procedure is completed, once it is clarified, what you have to do, you have to maintain the pH. Generally, the fluid, diluting fluids, what you're preparing should be neutral pH. So 0.1 or 2 here and there will be accepted, but it cannot be neither acidic nor basic. So generally maintained at 7 pH, and then this fluid what you have prepared has to be transferred to the 100,000 ml flask and sterilized by autoclaving procedure, made by maintaining at 121 degrees for 15 to 20 minutes. That is your fluid A. And if at all, if you add 1 ml of polysorbate 80 to your fluid A, then it becomes your fluid B. So this fluid B is generally used when you have the product, when the product to be tested contains lecithin or oily substances. Under such conditions, you generally prepare your fluid, use your fluid B. Now coming to your the most important methods, that is testing methods. Now how you test your products. Now talking about the testing methods, generally you have two methods of testing, two types of testing methods. One is membrane filtration method and second one is direct inoculation method. So when you talk about the membrane filtration method, now talking about the membrane filtration method, generally this type of method is used when the sample contains oily substances, or when it contains an ointment that can be solubilized in in solution, or if the sample is in powder form, it does or a liquid that contains with antimicrobial agent, or any solid that does not contain antimicrobial agent but it is not soluble in culture media, or if at all the products, if the the sample product is more than 100 ml, under such conditions you go for membrane filtration technique. One is oily substances, second one is liquids which are ointments which are soluble in the solutions, third liquids which contain antimicrobial activity, fourth solid substances which does not have any antimicrobial activity but still can be cannot be solubilized in your media, and fifth, if the quantity is more than 100 ml, then generally we go for membrane filtration technique. Now how you proceed for your membrane filtration method means, here as we are saying, it is a filtration method, and filtration method means you have to use filters here. So generally when you're using filters, you have certain standards in order to maintain the this filtration, this one. So what are the standards of the filters means, whatever the membrane filter you are using for sterilization procedure, that filter should contain a pore size of not more than 0.45 micrometers and a diameter of 47 mm. That is the standard measurements used for selecting a membrane for performing your test for sterility. Right? Now, this filtration membrane, so that is the standards of the filter. So what we are saying, whatever the membrane filter which we are using for sterility testing should contain a pore size of not more than 0.45 micrometers and a diameter of 47 millimeter. And whatever the filtration membrane or whatever the filtration assembly we are taking, everything has to be sterilized first. Now after sterilizing, what you have to do, you have to take the sample and pour it through the filter. Once the filter is product is filtered, then what you have to do after filtration, if it is a liquid, then you have to directly pour it. If it is oil or viscous substance, then you have to dilute it with suitable diluting fluid and then pour it. After that, what you have to do, you have to wash it, wash the membrane with what you have to do, you have to take your after pouring the, after filtering the pharmaceutical product, you have to wash the membrane with 3 successive, wash the membrane 3 times successively with 100 ml of fluid A. That washing means you need not scrub it and all. Just put the membrane, pass fluid A 100 ml through the membrane. Like that, you have to do it for 3 times. After that, take out the membrane aseptically, cut it into 2 equal halves. Then one part of the membrane has to be immersed in 100 ml of soybean casein medium and incubated at 20 to 25 degrees, and the other half in thioglycolate medium and incubated at 30 to 35 degrees. And both the mediums has to be, in both the mediums, the membrane has to be incubated for not less than 14 days. After that, you have to read the results. How you have to interpret the results, I'll let you know. So that is the general procedure for your membrane filtration technique. Now, you need to go for certain modifications if at all the formulations are not in proper form to pass through the membrane filter. For example, if there are oils or oily substances, if the viscosity of the oil is not very high or if it is low, you can directly pour the oil through the membrane. But if at all, if the viscosity is more, then what you have to do, you have to add the diluting agent such as your isopropyl myristate, which does not have any antimicrobial activity, and then pass the liquid through membrane filter. And then after passing the membrane filter, you have to wash it with fluid B for 3 times. As I told you clearly, when we are preparing the fluids, fluid B is generally used when the product contains oil or lecithin. So since it is oily substances, you have to wash the membrane for 3 successive times with fluid B. After washing with fluid B, take out the membrane, cut it, and again the same procedure, 1/2 in soybean medium and the other half in thioglycolate medium, and incubate it. If at all the product is an ointment or a cream or emulsion, then what we have to do is we have to take the product, required quantity, heat it to not more than 40 degrees, and then dilute it with suitable diluting agents such as isopropyl myristate, if at all, if it is necessary, and to maintain a concentration of 1% weight by volume. After that, procedure is same. You have to filter it rapidly through filter membrane, wash it with fluid B, and then go for the cutting process and then separately incubate it. If at all you are using the product to be sterilized, tested is an antimicrobial agent or an antibiotic, then what you have to do is, if it is liquid, directly pour it through the membrane filter. If at all, if the product is in solid form or a powder form, what you have to do is you have to take the required quantity to be tested into 100 ml flask, then add 100 ml of fluid A, mix it properly, and then pour it through the membrane filter. In case if the product is either penicillin or cephalosporins or any antibiotics, then you need to add your penicillinase enzyme to the fluid A solution, which is used for washing the membrane. Why? Because since we are using an antibiotic, it has antimicrobial activity. So even if contamination is present or even if microorganisms are present, they might not show the growth of that particular organism when we are testing. So in order to nullify the activity of that particular drug, the microbial activity of the drug, neutralize the activity of the drug, we are adding a penicillinase which neutralizes the antimicrobial activity of that particular antibiotic, and then carry out the procedure. That is how you generally carry out for your antibiotics. And in case of your disposables like your syringes or your your band-aids and your cotton swabs and different things. So if they contains a single batch or if it is a multiple stock batch, then you have to take 2 to 3 numbers from that. If it is a single one, you have to directly put it. And in case of syringes, what you have to do is you have to take the syringe and the needle, draw the fluid through the syringe, and after drawing the fluid through the syringe, collect the fluid that has been drawn into the syringe and then filter that fluid through the filter membrane and take out the membrane. Again, procedure is same. Wash the membrane 3 times with the fluid A, and if it is oily substances with fluid B, and then cut it into 2 halves and then incubate it in both the medias. So that is how you generally perform your membrane filtration method. Now talking about the second method, that is your direct inoculation method. Here it is saying directly inoculated. So how you have to do? You have to take the sample, directly put it on the medium, either by using sterile pipette or a sterile syringe, and then go for your under aseptic conditions and go for incubation. If at all, generally what you have to do, you have to take the sample, put it on the medium, mix the medium with the properly with the mix the sample properly with the medium, and then if at all it contains, if the product contains any antimicrobial activity, then it has to be neutralized with your penicillinase enzyme, and then incubate it in different media, soybean media and thioglycolate media at required temperatures, and then the results has to be tested. Now here also you need to go for the modifications process. Now what modifications here is, if at all they are oily or oily substances, like if the whatever the products you are preparing or whatever the this you are testing are oily or oily substances, then the modifications what you have to do is, you have to take the sample, put it on the media, and before adding it to the media, you have to add an emulsifying agent such as polysorbate 80, which does not have any antimicrobial activity, to the media into which you are adding your sample, and then go with the procedure. Similarly, you have to mix it properly, and then allow it to, and if at all antimicrobial activity is there, you have to add penicillinase, and then incubate it, and then you have to incubate it in both the medias, and then check it. If at all, if it is an ointment or a cream, then what you have to do, you have to take the sample and take fluid A. What you have to do, you have to, fluid B, because it is oil or ointment, creamy substance. So what you have to do, take the sample, take 1 ml of the sample and add it in 1:10 ratio. And after that, from that you have to take 10 ml of the sample, and to this you have to add your polysorbate 80, that is diluting emulsifying agent, and then take 10 ml of the sample and add it to 80 ml of your medium, and then incubate it. That is one of the modification. And if it is surgical dressings, as I said, you have surgical pads, you have gauze pads, gunge pads, and different pads. You have your band-aids, different surgical dressings are available. So if it is multiple dose containers, you have to take 2 to 3, or if it is single dose, take the entire content, put it in the medium, and then directly incubate it. So this is how you generally perform your test for sterility. Now after incubation, after 14 days, you have to read the results. Now how you interpret the results is very, very important. Now talking about the reading of the results, there are different steps here. First thing, if at all no growth, then we can easily say that the product is sterile and the product has passed the test. If at all there is any growth of the organism in the media, then what we have to do, you have to take that and keep it aside and perform the, you have to repeat the test again with original test. Like original sample has to be taken, and again it has to be repeated. And if at all, if there is growth, then you cannot use it. If there is no growth, then you can say that it has passed. So what are we saying? If no growth, the product passes. If at all there is growth, keep that aside, take this original product again and perform the test again. If at all, again, if you see the growth, then it fails. If there is no growth, it passes. Then, in case if there is any microbial growth found, try to isolate the organism from that. And this, if the, again, after what you have to do, first, as we are saying that if there is any growth, you have to keep that aside. Then isolate the organism. Even if the second time, if you perform the test and if you have the same kind of organism, that means it fails. If the organism is different kind, then again you have to perform the test with taking the double the number of samples. And if at all there is no growth, it passes. If there is growth, it fails. So first, no growth, passes. If there is growth, keep the particular medium aside and take the original product again and repeat the test again. So from the medium what you have kept aside, try to isolate the organism. And even after repeating it, if there is any growth, then it fails. So you have to check the organism in the first media and the second media. If the organism is same, then the test fails. If the organism is different, Then again, you have to repeat it for the third time with double the number of samples. And if at all the organism, if there is no growth, it passes. If there is growth, it fails. So this is how you have to interpret your test for sterility. So this is very, very important for each and every pharmaceutical product. You cannot simply say that the product, we have manufactured it in aseptic condition, so we are going to release it in the market. No. So this step is must in before releasing any product into the market. So test for sterility has to be performed for all the pharmaceutical preparations, irrespective of their use and irrespective of their type. You just cannot say it is required only for injectables, ophthalmics or something. No, for any pharmaceutical product, this test, including your surgical items, this test is required. So this is how you interpret your results. This is how you perform your test for sterility. With this, we have completed this topic, and you can go through this topic. You find this topic in different books like Ashutoshkar. You have Nirali Prakashan. You have Chandrakant Kokate. So these are the references books. And with this, we have ended the topic. Let's meet with another topic in your next class. Thank you.